Now, for our objectives, we have 1. Illustrate the law of cosines. 2. Solve a given set of oblique triangle problems using the law of cosines. Now, recall that the law of sines is applicable in solving triangles when the following cases are present. That is case 1, when two angles and one side are given, or this is also known as the SAA case or the ASA case. Case 2, when two sides and an angle opposite one of the sides are given. This is also called the SSA case or the ambiguous case. Now, when the law of sines cannot be used, then we will be using the law of cosines. Now, let us first derive the law of cosines. Let's find out how these formulas for the law of cosines came about. So, we start with an acute triangle. Now, the same can be shown for an obtuse triangle. So, this is our triangle, our acute triangle. Now, drop a perpendicular segment with height h from C to the opposite side. So, this is it. This is our h. Okay, so h came about when we dropped a perpendicular segment from C going to the opposite side. Okay. Now, the result is two triangles within the larger triangle. So here, this is the first triangle that was formed, and this is now the second triangle that was formed. So, two triangles within the larger triangle was formed. Now, since the length of side AB is C, okay, we let the length of this side be X. And so therefore, the length of this other side of AB will be C minus X. Okay, again, since the length of side AB is C, this side of triangle 1, we don't know the length of this, so we let the length of this side be X. Now, if this side is X, therefore this other side, which is the side of triangle 2, will be C minus X. Because if you add X plus C minus X, you will get C. Right? Now, use the Pythagorean theorem for both triangles. Now, recall the Pythagorean theorem, which is C squared equals A squared plus B squared, where C is the hypotenuse or the longest side of the triangle. Now, for triangle 1, it will be x squared plus h squared equals b squared. Now, notice that for triangle 1 here, b is the hypotenuse. That's why we have this formula. Now, for triangle 2, the hypotenuse is a. A is the longest side of triangle 2. Therefore, the formula will be the quantity c minus x squared plus h squared equals a squared. Now, solving for h squared, we have for triangle 1, so transpose x squared to the other side. So we will get h squared equals b squared minus x squared. For triangle 2, if we solve for h squared, then just transpose this quantity c minus x squared to the other side or to the right side. So we will have h squared equals a squared minus the quantity c minus x squared. Okay, next. Now, since the segment of length h is shared, set h squared equals h squared for the two triangles. Or in other words, equate triangles 1 and 2. Okay? Since triangle 1 has this formula, triangle 2 has this formula, notice that they both have h squared on one of the sides of their equations. Therefore, equating these two triangles, we have b squared minus x squared, this is from triangle 1, equals a squared minus the quantity c minus x squared. This is from triangle 2. This one on the left is h equal to h squared in triangle 1. This one on the right, this expression on the right, is equal to h squared in triangle 2. Now simplify the binomial, the quantity c minus x squared. So simplifying this, we have b squared minus x squared equals a squared minus, if we expand this binomial, we get the quantity c squared minus 2cx plus x squared. Removing the parenthesis or this grouping symbol, we will have this equation. B squared minus x squared equals a squared minus c squared plus 2cx minus x squared. Now notice that there's a minus sign outside the parenthesis. Therefore, all the signs of the terms inside this parenthesis will change. That's why c squared became minus c squared, minus 2cx became plus 2cx, and plus x squared became minus x squared. Then we add x squared to both sides. So x squared here on the left will be eliminated. So what we will have now is b squared equals a squared minus c squared plus 2cx. Okay. So the x squared term on the left and on the right side of the equation was eliminated. And then we isolate a squared, or in other words, put a squared on one side of the equation. So if we isolate a squared here on the right side, we transpose all the terms here to the left side. So on the left side, we will have b squared. This minus c squared will be transposed to the left, making it plus c squared. And this plus 2cx, if we transpose it to the left side of the equation, that will be minus 2x equals a squared. So we have isolated a squared. Now, by SOHCAHTOA, cosine A will be equal to x over b, right? Because cosine of an angle is equal to the adjacent over the hypotenuse. And in the first triangle, The adjacent side here is x. The hypotenuse is b. So cosine of angle A will be equal to x over b. Therefore, x will be equal to b cosine A. If we cross multiply this, then x will be equal to b cosine A. Now, replacing x here by cosine A, we will get b squared plus c squared minus 2bc cosine A equals a squared. And this is how we are able to find the formula for a squared under the cosine law. Okay. Now note that if we drop the perpendicular line segment with length h from angle A or B to the opposite side, we will derive the other two forms of the law of sines, namely the formula for b squared and the formula for c squared, which are this. Which brings us to the formulas under the law of cosines. So by formula, the law of cosines is stated as follows. A squared equals b squared plus c squared minus 2bc cosine A. B squared is equal to a squared plus c squared minus 2ac cosine B. And c squared equals a squared plus b squared minus 2ab cosine c. Now, it's quite easy to memorize these formulas if you want. You just take note of the pattern. So if you're looking for the measure of side A, then notice that here you will have b squared and then c squared and then bc here, okay, and then angle A here. So if you're looking for side A, you will use angle A here. All the others will be the other two sides. So if it's b squared here, then here it will be a squared and c squared, and then 2ac cosine B, angle B. So if you're looking for c squared, you're going to use all a's and b's here except for the angle. So the angle here will be angle C. In other words, the square of any side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of these two sides and the cosine of their included angle. Now, if we manipulate the formulas here on the left, we can get the formula for cosine A, cosine B, and cosine C. So if we try to manipulate this first formula, we will get the formula for cosine A, which is this one. So cosine A will be equal to b squared plus c squared minus a squared all over 2bc. If we try to manipulate the second formula here on the left, then we can get the formula for cosine B. So cosine B will be equal to a squared plus c squared minus b squared all over 2ac. And manipulating the third formula here on the left, we can get the formula for cosine C, which is a squared plus b squared minus c squared all over 2ab. Now just take note of the pattern so that you can easily memorize these formulas. Now, If we have the formula for cosine A, then we can already solve for the measure of angle A. How do we do that? By using the inverse functions. Okay. Now, the law of cosines apply when we are given these two cases. Case 1, the SAS case, when two sides and the included angle are known. So you have two sides, the angle that they form, that is the included angle. That's why from the name itself, SAS, you can see that A is sandwiched between the two S's, two sides. And the law of sines also apply when we have this SSS case, which is the case number 2, when three sides are known. So again, take note, law of cosines apply when we have two sides and the included angle, as well as when we have all the three sides of the triangle. Now, let's try to discuss case 1, when two sides and an included angle are given, or the SAS case. Let's have an example falling under case number 1. Okay, so let's have this problem. The two sides of a triangle are 25 centimeters and 40 centimeters, and the included angle is 48 degrees. Find the measure of side C. So here you're given two sides and an included angle. So clearly this problem falls under the SAS case. Now, so this will be our illustration. Okay. So side A is 25, side B is 40 cm, and angle C is 48 degrees. This is the included angle, the angle formed by the two sides. Right. Now let us solve for side C. Since we're given sides A and B, let's try solving for side C. So since this example falls under the law of cosine, specifically under case 1, so we can use the formula for C squared. Okay, so we can use this formula, C squared equals A squared plus B squared minus 2AB cosine C. By substitution, so we try to replace now the given values here. So C squared equals 25 squared, since A is 25, plus 40 squared, since B is 40, minus 2 times 25 times 40 cosine of 48 degrees, since angle C is 48 degrees. Therefore, C will just be equal to the square root of this entire expression on the right. And by using your calculator, you will get, or you will see, that C is approximately 29.78 centimeters. This is rounded off, correct, to 2 decimal places, or to the nearest hundreds. Okay, so now we now have the measures of sides A, B, and C, as well as angle C. Now let's try solving this time for angle A. Okay. Again, when the instruction says solve the triangle, then we mean find all the measures of the three angles and all the measures of the three sides of the triangle. Now, in solving for angle A, we can use either the law of cosines or the law of sines. Now, using the law of cosines, we know this formula: cosine A equals b squared plus c squared minus a squared all over 2bc. Why are we using this formula? Because we are trying to solve for angle A. And we're given side B, side C, and side A. The only unknown here is angle A. Therefore, we can use this equation indeed. So, by substitution, we will get this. Okay, so just replace the variables here with their given values. And to solve for A, for angle A, again, we will use the inverse function. So A will be equal to the cosine inverse of this entire expression on the right. And by using your calculators, you will arrive at this value. A is equal to 38 degrees, 36 minutes. Okay, so this degree measure is expressed in terms of degrees and minutes. Now, using the law of sines, we have sine A over A equals sine C over C. Okay. Now, we can use the law of sines here because this example falls under the SSA case. Because here, two sides are given and an angle opposite one of the sides. So we now have the measure of angle A here on the left side. So let's see if we will arrive at the same value for angle A if we use the law of sines. Now, why do we use this? Why can we use this proportion? Because side A is given, side C is given, so this is checked, and also angle C. Angle C is also given, right? So the only unknown here is angle A. So therefore, we can use this formula. Now, by substitution, we get this. Sine A over 25 equals sine 48 degrees over 29.78. Okay, so sine A will just be equal to 25 sine 48 degrees all over 29.78. Okay, so we did cross multiplication and we divided both sides by 29.78. So to solve for angle A, we will use the inverse trigonometric function. So A will be equal to the sine inverse of this expression here on the right. And using our calculators, we will get this value. Angle A equals 38 degrees, 36 minutes. Okay, so this time, let us now solve for the other missing angle, which is angle B. Now, since the two angles are already known, then we can now solve for angle B using the formula B equals 180 degrees minus the quantity A plus C, or you can use B equals 180 degrees minus A minus C. So by substitution, we get this. So replace A by 38 degrees, 36 minutes, and replace angle C by 48 degrees. And you will get, sorry, this should be B. So angle B equals 93 degrees, 24 minutes. Now let's have another example falling under case 1, the SAS case. If A equals 112 meters, B equals 135 meters, and C equals 104.3 degrees, solve the triangle. So here the given are, okay, side A, this is a side B, another side, and side C, which is an angle. Okay, so if we try to illustrate, this will be our triangle. So this is side A, opposite angle A, of course. This is side B, opposite angle B. And this is angle C. So this is side C. So clearly, we are given side, angle, side. So this falls under SAS case. And therefore, we can use cosine law. Okay. So again, you will see that in this example, C is the included angle because angle C is the angle formed by these two sides A and B. Now let's solve for side C first. Okay. So here is the triangle. We have drawn it. Okay. So find the measure of side C using the law of cosines. So we will use the formula for C squared. Okay. By substitution, we will have this. So substitute the values of A, B, and angle C. Okay. So C will just be equal to, sorry, this should be C, not C squared. So C will be equal to the square root of the terms here on the right. And using your calculator, you will get this value. Side C is equal to 195.55 meters. Okay. So now we have the measure of side A, side B, angle C, and side C. Now let us now solve for angle A. Now to solve for angle A, we can now use the law of sines since it entails less computation. So under the law of sines, this is the formula that we can use. Sine A over A equals sine C over C. Why this formula? Because you're given side A, so this is check. You're given angle C, so check. And you're also given now, we also now have the value for side C. So the only unknown here is angle A. So we can use this formula indeed. Now solving for sine A, we have sine A equals A sine C all over C. Okay. So solving for angle A, so A will be equal to sine inverse A sine C all over C. And then substitute the given values, we will have this. So A will be replaced now by 112. Angle C will be replaced by 104.3 degrees. And side C will be replaced by 195.55. So using your calculators, you will get 33.71 degrees or 33 degrees and 43 minutes. Okay, so we add this angle A now to the values that we know, and let us now solve for angle B. Now, to solve for angle B, we can now use the angle sum of a triangle. So the angle sum of a triangle states Simply that the sum of the angles of a triangle is 180 degrees. So therefore, angle B will just be equal to 180 degrees minus angle C minus angle A. So substitute the values for angles C and A. You will have this. Therefore, angle B is equal to 41.99 degrees or 41 degrees 59 minutes. Now, you may proceed in answering activities 2.1, 2.2, and 2.3 of your learning package 1. So answer in your printed learning modules first, and then upload your answers in the LMS when you're done reviewing your answers in your printed modules.